Chapter 3, Lesson 3 of Pre-Calculus, we're going to look at logarithmic functions and their graphs. And as a way of introducing this, I want to look at inverse operations and how we use those to solve equations. If I take x and I multiply it by 3, and that gives me 6, how do I determine the value of x? Well, the way we do this is to do the inverse operation, or to undo what's being done to x in order to determine the value of x. In other words, here we have 3 times x. To determine the value, I undo that, or I use the inverse operation. I divide by 3. I undo the multiplication operation in order to determine the value of x being 2. And that's how we solve equations. The same as if we have division. If I have x divided by 6 is equal to 3, how do I undo this, or how do I determine the value of x? Well, if x is being divided by 6, I undo it by multiplying by 6. And in doing so, that undoes the division and gives me the value of x. And the same is true when we're doing addition or subtraction. Subtraction undoes addition, and addition undoes subtraction. And that's how we solve equations. Well, we just spent a couple of lessons looking at exponential functions. In other words, we've had, let's say, 3 to the x is equal to 6. Well, how do I determine the value of x? I have to undo this number being raised to a power. Well, what's the inverse of raising something to a power? And we don't have anything really up until now. And actually what we're going to do is take the logarithm of both sides, or we're going to use logarithms in order to do that, because exponential functions and logarithmic functions are inverses of each other. Okay, so we'll come back to this in a moment. So let me take a look at this and explain it a little bit more. We know that if we take a horizontal line test, then the inverse will be a function. So in other words, here we have the exponential function that we have been looking at. If we apply the horizontal line test, meaning it doesn't cross this in more than one place, we know then that the inverse of this is also going to be a function. So this is the exponential function. It passes the horizontal line test, so the inverse is also a function. So this red graph here would be the graph of the logarithm function. It is the inverse of the exponential function. So kind of tying this to what I was talking about earlier, then we're going to use logarithms to solve exponential equations, because logarithm will undo exponential, so to speak, and we're going to use exponentials to undo logarithm equations because they're inverses of each other. So I kind of want you to think about these as being inverse operations of each other. They are inverse functions, and you can see that here as we look at the graphs of these. Now let's go back to this, what we were looking at before, and let's take a look at a couple pieces of this. This number that's being raised to a power is called the base, and this is, we know, is called the exponent. Okay, so how do we undo this? And in order to solve this for x, we need to get the x out of the exponent down here on the regular line that we're used to solving in order to solve it. And the logarithm is going to help us do that. So let's take this exponential function real quickly and put it in general terms, meaning let's change 3 to the letter b. So b represents my base. And then we still have x here, and so that's still going to be my exponent. Okay, and that's going to give me some y value. So this would be the general form of the exponential equation. And again, we've talked about this in the last lesson. A times b to the x is y. Here a would just be 1. Okay, now we talked earlier in the year about making or determining the inverse. Okay, how do we determine the inverse? Well, you remember in the inverse situation, the x becomes y and the y becomes x. So let's change this to b to the y is equal to x. And again, now our problem is, how do we solve for y? Where does y, how do we get y out of the exponent down here so that we can solve it for y? And again, the inverse operation that we're going to use is the logarithm. So if we take this equation and we solve it for y, what we're going to end up with is this. Y is going to be equal to log, there's b of x. So this is the exponential expression. Okay, this is the exponential. And then this is our logarithm equation, or logarithm. Okay, so y has been solved for by finding log. Now, that may sound a little bit confusing, but let's tie it together with what we have here. So where is this b? What is this b? Well, this b is simply this number that's being raised to this power. So this b represents the base. And where did this x come from? Well, this x, you see, is the value that we got when we raised this to this power. So what is y over here? What does this represent? Well, this is the exponent. So this is the exponent from this equation here. This is the base from the exponential. And then this is the former y value that we got when we raised this to that power. Okay, so one way to look at this word logarithm is to recognize that it's simply asking the question, what's the exponent? Logarithm really is just another word for exponent. Okay, so logarithm is really just another word for exponent. And what I like to think of it as is asking a question. Logarithm means, what is the exponent? Okay, and then we ask the question. So what is the exponent of this number, this base, that will give me x? Okay, and so that's what this side means. What is the exponent, log? What is the exponent of this base that will give me this number? Okay, so this is the question you want to ask yourself, and this is the way you want to look at a logarithmic expression. And so the answer to the question is over here, the y. So the y is the exponent. It's the answer to this question. What is the exponent of this number that will give me this number? What is the exponent of this base that will give me this number? And then the y is the answer to that question. Okay, so this is what the logarithmic equation looks like. With these two expressions, then, you can see that we have the same pieces in play, they're just in different places. So the base of the exponential expression is the base of the logarithmic expression. The exponent of the exponential expression is the exponent of the logarithmic expression. And the value that you get when you raise this base to this power is the value that you get when you raise this base to this power, and that value goes here in the logarithmic expression. Now there are a couple of restrictions as to what b and x can be, so let's take a look at those. Looking at these restrictions then, we have here that x cannot be greater than 0, or x, excuse me, must be greater than 0, and the b value, or the base, must be greater than 0 and cannot be 1. So let's take a look at why those restrictions are. So here's our logarithmic expression, and here's the inverse expression, or the exponential expression. So let's take a look at this part first. B has to be greater than 0, so we're only looking at bases that are positive, so no negative bases, and this base cannot be a 1. Now, why can't this base be a 1? Well, if we think about this, if the base is a 1, we're asking for what's the exponent of 1 that will give me this x value here. Well, if the base is 1, this x value is always going to be 1, because 1 to any power is 1. 1 squared is 1, 1 to the 4th is 1, 1 to the 8th is 1, 1 to the 100th power is 1. So if my base is a 1, this expression becomes useless, because this x value is always going to be a 1. So for that reason, we're not going to use a base of 1. So the b can never be a 1 for that reason. And we're only talking about positive numbers now. We're only going to use positive numbers for our base. Which then leads us to why the x value, this value here, has to be a positive number. And why do you think that is? Well, if the base is always positive number and you're raising it to some power, this x value that you get over here cannot be a negative number, because you can't raise a positive number, multiply it by itself, any number of times and produce a negative number. A positive number raised to any power is always going to be a positive number. So for that reason, this x value will never be negative. So those are the two restrictions that we need to be aware of. So if you come across an expression where this x value here is negative, it's undefined, okay? Because again, there's no base in the world that you can raise, a positive base in the world that you can raise and multiply it by itself and get a negative number. So that is undefined if this is negative, and the base, if that is negative, is also undefined because we're only using positive bases. So those are the restrictions to the logarithmic expression, and those are why those are restrictions. In the next video, we'll take a look at then evaluating these logarithmic expressions using the inverse operation.